Hi, everybody. It's meteorologist Joe Chaffee. I'm feeling a little better today. I had a really bad bowl of chicken soup last night, and I think it gave me some food poisoning. And I haven't actually been in a very good frame of mind this morning to cut my video. I just wanted to shut the ringer off on the phone. However, I'm feeling a little better. So I think I have enough energy to start looking at things. We have about almost 3 inches of snow outside my window, with snow coming down moderately, probably at about an inch an hour, maybe a little bit less, but it's definitely accumulating. Everything is working out as advertised, thank God. I was a little nervous yesterday with the forecast, but that's always the case. Sort of like having a baby. It's you're nervous right up until that first flake starts falling, just to be sure. Okay, so the next thing is that we are going to focus on the possibility of a major storm developing in the eastern part of the United States, and I want to take you through the GFS first, because this has a solution that is possible, and that is what we call a coast hugger. And what that means is that warm air comes in and changes snow after several to many inches to sleet and then rain for the immediate coastal areas, but it stays mostly snow inland of the coast, and those areas get buried with a foot plus. And the GFS is telegraphing the operational GFS, which is what we're seeing here, is telegraphing that today, and it did during the overnight, although it's been doing a little shifting back and forth. And actually, this model run does a couple of odd things as well. So let's take a look at what happens. So, of course, we've got this low that's moving out now. So the snow will be tapering off and ending during the afternoon, last at the coast, and then out. And then it's very cold air comes in for tonight and for the weekend. So another bitter cold, at least from the standpoint of March 11th and 12th. It's going to be bitter cold. Now, here's the system that is dropping down into the Western Gulf and just kind of gets stretched out northeastward into the southeastern part of the United States. And you start to see lower pressures down across Florida and into the eastern Gulf. You also begin to see energy coming into the northern plains that's dropping southward. So this is that northern stream of energy that we're dealing with. And now we've got a surface low developing off the Florida coast. And of course, this trough swings down and around and lifts up this surface low. And as the trough goes, it's tilted northwest, southeast. A lot of energy here. This storm is going to intensify very rapidly. But you'll notice that it goes up inland of the coast. It's sitting here right in western Delaware. Snow into northern New Jersey, Long Island at this point, heavy snow on the northern fringe. And, as I said, it would be several to many inches before it changed to rain. And after that, the model, for whatever reason, and I guess in response to this upper trough just digging down and cutting off, takes this surface low and flips it out straight east, or almost east-northeast, or from western Delaware to south of Long Island, east of the New Jersey coast. A pretty strong wrapped up low. I mean, this certainly will be nor'easter conditions for up for the northeast, for the mid-Atlantic and northeastern, but particularly from the New Jersey shore on north and east into New England. And then the low goes west of Boston and kind of just rotates up there and then translates eastward. So it's a little bit bizarre, mainly because of what's going on with the energy in the upper air, which I'm going to show you right now. Now, here's the problem with the GFS, at least in terms of the coast, okay? But right in here, the GFS has this really, really intense feature, and you can see it here. There's this northern features digging down and around, and there's the axis of the trough. The axis of the trough is already negative when it's west of 85 degrees west, okay? And that spells coast hugger if that's correct, and as opposed to an offshore track, okay? Because the trough axis is too far to the west. If it were to go negative, say here, then you're talking more of an offshore track, but as opposed to one that's just barely onshore, okay? And by the way, I am not sold on this by any means, because the other models up until now are not quite as dynamic with the trough as, not that it's not dynamic, that's probably incorrect to say, but that the trough axis on the other models, it takes longer for this to become one cohesive unit. It does it further east, so as a result, you get an offshore track. But you can see this big upper low just drops down into Ohio and moves right over New Jersey and Long Island, and then moves to the northeast. Now, the upper feature is here, but the surface low at this point on the GFS is somewhere here in southeastern New England. So that's that model's view. Okay, I want to take you to back though. I want to show you. This is the European from last night at 84 hours. Actually, you know what? I can go. We'll go for Tuesday morning or Tuesday evening. There it is. That'll match up. Okay, so here's the GFS. This is the European's upper air from last night. Okay, and look at that, look at the difference in what the two models are doing. What the European is suggesting is that, yeah, you've got this northern energy here, but this feature that swings up from the south actually swings up separately and goes up and around it. So as a result, the European had an offshore track, a wrapped up cyclone with an offshore track. And I'll show you what it did on the surface from last night. And I'm buying a little time here because this way maybe the new Canadian will be out. And this is what the European did last night. So from a low south of Louisiana to a low sitting southeast of Charleston in the ocean that goes northeast and explodes as it's sitting east of New Jersey, south of Nantucket. This track would bury all of the coastal areas with 1 foot plus snows if it verifies. And the reason it's different is, and you can see with the colors, the colors back here, actually, that's the upper air that I showed you just a little while ago. Instead, it's done in different colors. So you can actually see the trough here. See that there's that southern part of the trough. Here's the northern energy. It's taking longer for them to come together. So the model keeps them almost as separate entities. And there's that southern energy that's lifted up as a separate feature, while the north comes down and around and eventually gets ejected out to the northeast. It's a little more progressive on the European than it is on the GFS. The GFS is not progressive at all. The European is a little more progressive. Now, in terms of what we have as far as supporting some of these models, you know what, I was going to go to the ensembles, but let's go to the Canadian, see if we got enough of the Canadian in. All right, we do have out to 178 hours, which is not really far enough on this view. So I will switch. Let's see if the other views are out yet. Only out to 78 hours, but we can get at least a clue here. Here's the Canadian at 78 hours. Here's the GFS, if it would load. There it goes. You can see how much deeper and further west the GFS is. Look at where the trough position is on the GFS. It's way back in here. Okay. Look where it is on the Canadian. And it's going to switch over. You see how much different it is? It's much for the trough axis, but the GFS's trough axis was back in here somewhere. Okay, the Canadian is much further east. It's a little more progressive. So the trough, instead of going negative, perhaps back here, might on the Canadian, when we look at it in a little bit, goes negative further east, and that would, if that's the case, should favor an offshore track. I'll just punch up the surface really fast to see if that's in yet. And then if it's not, we'll go to something else. And then I'm going to go to the ensembles, and then I will. Oh, it's out to 102 hours. So let's see what the Canadian does. And you can see the Canadian has an offshore track. It's also not as deep, which is very interesting. But the Canadian has an offshore, not as deep track with the low as it goes by to the northeast. Okay, so from that standpoint, you see the difference. Now the Canadian, again, it's not the most reliable of models, obviously, and I've made reference to the fact that it's really it's only been right maybe twice since the Treaty of Westphalia was settled. But we're at a situation here where, since all the models are showing virtually the same thing, with each one having its own variation, we want to look at it to see what option it holds, or at least give us an idea. If we understand why it's doing what it's doing, it gives us an idea and how to, when we compare it up to the other models. And it has a much broad. You can see there's the dashed lines here, the thickness lines, which basically measure how cold or how warm the atmosphere is from the bottom up. You can see how it's more gentle in terms of the sloping. It's not sharp or V-shaped. It's got a much more gentler looking trough. So as a result, it has a much less developed low. Now, I want to go to show you the ensembles from last night for the GFS, because while the operational model of the GFS did what it did, the ensemble members did something very interesting. So I will put that up and show you where they're all clustered. Okay. Well, first off, this is the actual average of all the different models, all the different variations of the GFS. This is the average view of what it came up with. Even though the operational model did a coast hugger, the ensembles all shows an offshore track. Now, when we look at the actual members of that ensemble group, if we take a look at that, and you should be able to see. Now you see you know what? I'll get a little tighter with this, because this way we could see those little numbers. All right. It actually, on this map, unfortunately they don't have that's the tightest version they have. Okay. So unfortunately we have to kind of look as close as you can, but you see all these numbers: 91, 95, 89. Those are representations of surface lows that each ensemble member came up with, and it's all plotted on one map. And you can see where they're all clustered. There are only a couple of ensemble members that are showing lows out to the west, coast huggers. A vast majority of them are showing an offshore track, and they all seem to be clustered with very intense lows east of New Jersey, south of Montauk. Now, oddly enough, the GFS gets there today with the surface low, except that the first thing it did is to bring that low inland before it shoots it out to the east, which the ensemble members did not do. So they all seem to get to the same place, but the GFS today has an inland track before it moves out. So these are one of the things that we're going to look at, and what we're looking for. We can also look at the European ensemble members from last night and see what they did. Actually, we only can see the average. We can't see each individual member. But why is it not letting me do the surface like I did before? Let's see. EPS. That's very strange. Oh, there we go. Okay. So here's what the European ensemble did last night. And, basically, again, an offshore track, because of the fact that the trough on the European also a little more progressive, not as negatively tilted and as deep as the GFS. They all would make intense storms, but with the axis of the trough on the European and Canadian models further east, you're going to have the offshore track favored. So we'll give the Canadian one more view, see how much of that we have. And let me put the precip only out to 102 hours on the surface map. Okay, so that shows you where the Canadian is with that 91 low. So you know what? We have enough. We can look at snowfall forecasts. So let's show you what the models come up with. And you'll see the difference between a coast hugger and I'm going to have to go to the 24-hour forecast, because we need to scrap to subtract out today's event, which is still going to be reflected on the models. So here's the Canadian with that weaker low. It shows, some heavier snows, but nothing crazy. Some 9-inch amounts and maybe some 1-foot amounts over the Delmarva Peninsula, 6 inches maybe up to Long Island and southeastern New England near the Cape. But inland areas get very little out of this because of that weak offshore track. Now let me go close up, and all right. I apologize. It seems to be having slight signal issues at the moment. All right, so here's the GFS. And this is what happens with the coast hugger. The heavy snows are all inland. Actually, even gets to a foot of snow in New York City in spite of the track. So with that inland track, what it's basically doing is it's telling you that you're going to put down very heavy snow in a matter of hours. That you could certainly, it'll be snowing at 2 to 3 inches an hour for a short time, and put down the bulk of your accumulations where the changeover to rain takes place. But it produces 1 foot plus amounts just inland of the coast and across eastern Pennsylvania, most of southern New York, and I'm not out far enough. This is only out through the evening on Tuesday, and then we go to Wednesday morning. Everything shifts because I'm showing you 24-hour snowfalls here. As far as areas to the south, across Virginia, looks like some ample snows with that low actually going east of Virginia. There might be enough cold air pinned down to produce a pretty decent snowfall in the Washington, D.C., Baltimore area, being shown with 1 foot plus snows on the GFS, and into southeastern PA, just west of Philadelphia, and then up into all of northeastern PA and into the Catskills. And of course, eventually this all translates to some degree as we move up into New England. So the bottom line at this point is we are no closer to figuring out the absolute specifics. I think we can say that the idea of a major storm along the East Coast is certainly strongly supported by the models today, and they continue to be supported run after run. By the way, one of the things is, this might be a good time. Let's go. I want to go show you the whole profile of the upper air, because you might ask yourself, you might be saying, well, how come these things change so much, and yet in this particular case the models are not changing very much at all? And the main reason is we only have here, when features become stretched out to the extreme, the models are only dealing with one or two or three very dominant features. Okay, all you have, just to show you, in the United States, we have the ridge in the west and the trough in the east, and a ridge coming in off from the Atlantic. That's all you have. Those three factors, and only one very, very dominant system, as opposed to a normalized atmosphere where you might have 4 or 5 different systems running around. So as one of them changes or gets altered to some degree, it winds up changing everything else down the road. So you see these different outcomes that the models do from run to run, and it's like, how you ask yourself, well, how did it go from doing this to doing that? And in a case like this, when you have very strong dominant upper air features like this, you have less variation. Models zero in on the main idea, which is great, because at least from that standpoint that that's going to happen. And the next battle, the next battle for you can go to the next battle for you to fight, which is, okay, what is specifically going to happen? So from that standpoint, let's just say this. And by the way, I just want to real quick run through the upper air. It still looks kind of blocky up there to some degree, but then here goes another one. Another strong upper air low that dives down from the Great Lakes right after St. Patrick's Day. You know what? I'm not even going to look at that. I'll look at that when I'm done with the video. I want to go back to what you might expect to happen. I'll go to the wide view so we can look at the weather across the United States. I don't want to leave everybody that's in other parts of the country out. Okay, and let's back up. Let's back it up. Okay, so here's right now. So here's our snow in the Northeast, across New Jersey, Long Island, southern New England, eastern Pennsylvania. I'm actually snowing fairly hard right now. I'm past the 3-inch mark. I'm just giving another look out the window in the last 20 minutes. Okay, so we've got some snows coming into the northernmost Rockies and in southwestern Canada. So that's that energy that drops down into the western Gulf and becomes eventually that coastal low. Here's that northern energy coming down. Now we're at Sunday night into Monday. And you can see what happens. The northern energy, see how that surface low just kind of races southeastward, and eventually the coastal low takes over, jumps out to the east before it goes north. It starts reacting with that big upper low and then pulls away. By the way, one thing that's going to come out of this, for those of you that are in Virginia, North and South Carolina, and probably into eastern Tennessee, this entire area in here, it's going to be very cold there. Probably some record low temperatures that are going to be set come Wednesday night, and maybe even again on Thursday night, or perhaps less so. But certainly Wednesday night into Thursday morning, it's going to be very, very cold. Let me just look. 2-meter temperatures. I mean, certainly for this time of year. It's not like, there we go. I mean, it has, by Thursday morning, it has temperatures below freezing into northern Florida. Look at the freezing line, how far south it gets. 20s down into southern Georgia, through most of South Carolina, all of North Carolina, teens in northwest Georgia, and on up through the mountains in western North Carolina. This is very, very cold air that's going to get drawn all the way down. Look at the temperatures down in South Florida. Temperatures that bottoming out in the 30s and low 40s. I mean, that's amazingly cold for March 10th to see that before we go back and start to moderate things. So let's move along through next week. And looks like we should have a halfway decent St. Patrick's Day. Next weather system, you know what, who knows with this? Looks like it wants to try to do something, but how much cold air is going to be around, who knows? That's sort of back in the land of speculation. But you see how when you look at the surface map, there really is only one dominant player here, the big low in the east. There really isn't too much going on anywhere else. And this is why when you have these big, strong features in the atmosphere, when models are pointing to the idea of making major storms, they do it they lock in early, and then there's not a whole lot of variation. As I said, you'll know that it looks like it's going to happen. Now we got to figure out: is it a coast hugger? Is it just offshore? Is it a compromise? It's somewhere in between. Maybe it's not as far offshore as the European has it, but not as far inland as the GFS has it. That's going to make for critical forecast decisions in terms of snow amounts. Now, as far as what we would expect to happen in terms of a timeline, so this is Monday night, and snow is already spreading up into Maryland and Virginia. By 1 in the morning, it's snowing to New York City and western Long Island, all of Pennsylvania, southwestern New York. Looks like it's already changed to rain at this point in the over the Delmarva Peninsula down into eastern Virginia. And by Tuesday morning, the surface low is sitting right over Delaware, and it's snowing hard just north of New York City, north and west into eastern Pennsylvania and into the Hudson Valley, and also into southern New England. Rain over Long Island at this point. Again, this is the GFS model. I'm not forecasting this. I'm just interpreting for you in terms of a timeline. And then this is at 1 o'clock in the afternoon. Very windy conditions, by the way, nor'easter conditions for sure. And then the low pulls away to the northeast, so that precipitation is over with by Tuesday night. But if this is an offshore track, as the other models are showing, then the timeline is not going to be what I just indicated to you. So at this point, the next step is to watch we saw what the Canadian did, so we know that it has a weaker offshore track. So now we have to watch for the European to see if it continues to show a weaker. Actually, the European showed a very strong offshore low, but it was definitely offshore. So we'll have to see if the European's upper air is consistent with what it showed last night, and as a result, different from what the GFS has been showing. And by the way, just real fast, I won't click to it, but the NAM model, which goes out to Monday, overnight Monday night, so 1 a.m. on Tuesday at this point on this run today, matches up better with the European than it did with the GFS. So, I often find that the NAM and the European, at times anyway, tend to get lockstep. So the fact, if the NAM were looking like the GFS, I would be concerned for a coast hugger at this point, more concerned. But the fact that it doesn't is, to me, certainly leaving the idea that all options are still on the table. So we will have continuing coverage, of course, right through the weekend with regards to this potential major winter storm that might affect the Northeast early next week. Again, I've made no definite specific forecasts. We're just looking at the weather features at this point, so I want to be clear. Be sure to check the latest website posts. There'll be numerous ones over the next couple of days on meteorologistjoechaffee.com for equally insightful analysis, more centered on New York City. You can check out Angry Ben's post on nycweathernow.com. And of course, download my app and subscribe to my forecast. Just 99 cents. The link will appear at the above, or if you're on my website, you can link from there. There's a link virtually on every page to get to it. It's $1 a month for New York City, Long Island, New Jersey, Hudson Valley, Eastern Pennsylvania, and again, just $1. And if you have stayed, this I think may be the longest video I've done, 27 minutes without a commercial break. If you've stayed this long and you like my video, you like my weather videos, thank you for staying. I really appreciate it, and I appreciate your patience. And do please feel free to subscribe to my YouTube channel, which is absolutely free. You just click the subscribe button that's somewhere over there on the page, and you'll get notifications anytime new videos go up, which is usually once a day. And when storms warrant, which they will this weekend, there may be multiple videos. And if you do subscribe, it really helps me tremendously with my standing with Google, because the more subscribers I have, the more Google is likely to freely share my stuff throughout that vast internet world that we live in. So everybody have a great rest of your Friday. If you're in the New York, Long Island area, New Jersey, Hudson Valley, just drive cautiously, even though main roads appear to be wet rather than white, but everything is accumulating on colder, grassy surfaces. And look who made an appearance at the end. He waited till the very end to come say hi. He's been takes naps in the morning. Little Koval, he's been such a good boy. He kept me company with my sour stomach today. There he is. Okay, everybody, say hi. Say hi to everybody at home. Okay. All right, folks. Have a great rest of your day, and talk to you soon.